Alright, so today we're going to think about the idea of complementary events. When we started this topic, we saw that probability is measured on a scale from 0 to 1, or equivalently from 0% to 100% chance. And so we're just going to see some implications of that today. So for example, suppose we have an archer who has an 80% chance of hitting a target. What's the chance he misses? All right. Well, the first thing you notice is that there's only those two possibilities. He either hits or he misses, right? And what we called that last time was the sample space. And so if you picture this green bubble being the set of all possibilities, well, he's bound to either hit or miss. And so we are certain that he's going to land somewhere in this bubble, right? Which means that all of the options, all of the possibilities in the bubble must add up to 100% in total, because we're certain to land somewhere in there, right? And we don't know whether he's going to hit or miss, but it's bound to be one of them. So let's picture the event of him missing as some little piece of this bubble. If that is him missing, then the rest of the bubble must be him hitting, right? And we're told that he hits with an 80% chance. And so the fact that the whole green bubble adds up to 100% should tell us then that the probability of him missing must be 20% to make up that 100 in total. So the takeaways from that, first is that the probabilities of all possibilities when you do an experiment or when something happens, the sum of all the individual probabilities must be 1. That when you add up each individual probability, they must all add up to 1 or 100%. Okay? And what this gives us is a nice way to think about the probability that something does not happen. Okay, so if we picture that something as a piece of this block, right? It's some event, we don't know whether it's going to happen or not, but it happens with this probability. Then the fact that it doesn't happen would look a bit like this, right? And what we said was that all of these must add up to 1. And so if you wanted to calculate this, well, you'd have to take the whole thing, which is just 1, and then you'd subtract that blue part. You'd remove that blue part, and so you would subtract the probability that that thing happens. So with the archer thing, it was a 20% chance of missing. That was just the whole 100% minus the chance of him hitting, because missing is the same as not hitting, right? In general, we call these things complementary events, right? When you have an event where something happens and the event where something does not happen, we call them complementary. And the way we write them, sometimes symbolically, is we put a little line over them. Okay, so a little line over the E would mean not E happening. All right, so let's see an example of this. We just read that a card is chosen at random from some playing cards. Now, it's not a whole deck of cards, and so we can't predict things that accurately here. It's chosen at random from some playing cards, but we know that the probability of a spade is 0.24, probability of a club is 0.27, and the probability of a heart is 0.23. We want to know the chance of each of those things. So we'll start with A and B, the black card and the red card. So again, we picture all possibilities as this green block here. We're told that the probability of a spade is 0.24, so we can think of the spades taking up 24% of the block. Right? The probability of a club is 0.27, so let's picture the clubs taking up 27% of the block. The probability of a heart is 0.23, so let's picture the hearts taking up 23% of the block. And we're not told anything about the diamonds, but let's just complete the picture. We don't know what it is though, right? All right, part A asks, what's the chance that we get a black card? Well, the black cards are just these two, the spades and the clubs put together. So the chance of getting a black card must be 0.24 plus 0.27, and you add them and you get 0.51 then. Part B asks for the probability of getting a red card. Now the red cards are made of the hearts and the diamonds, and we don't know what the diamonds are, so we can't do it in the same way. But what we do know is that getting a red card is the same as not getting a black card. And so what we can do is, rather than directly do it, which we can't do right now, we can just take the whole thing, which is 1, and we minus the probability of getting a black card, which we just got, the 0.51, right? And so we should know that that probability must be 1 minus 0.51, which is 0.49. Okay, that's A and B then. Part C asks us to find the chance of getting a diamond, that missing one that we don't know, right? Now, what we do know is that the spades, the clubs, and the hearts, they add up to, well, 0.24 plus 0.27 plus 0.23 is 0.74, right? And so that must mean that the rest of it, because all those probabilities of getting spades, clubs, hearts, and diamonds, they must add up to 1, and so the diamonds by themselves must be 1 minus 0.74, which is 0.26. Okay, so the diamonds must be 0.26, and we can get that by subtracting everything else from 1. What about part D, spades or hearts? So we'll get rid of that for now. If we want a spade or a heart, that means we want one of these two. Well, that means we can just add them up. So that's going to be 0.24 plus 0.23, which gives us 0.47. So no need to do any subtraction for that one. Okay, but the main ideas were that all possibilities, if we sum up all the individual possibilities, they must add up to 1 or 100% in total. Okay, and so to find the chance of something not happening, you can just subtract its probability from 1 or from 100%, and you can get what you want that way. Okay, thanks for watching. I'll see you guys next time.